Hi viewers, today let us see the Ohm's law concept with resistance are connected in series. So in this last class we have seen only one resistor used in Ohm's law concept. So one voltmeter, one ammeter, one resistance are connected. So according to the variation of voltage, how the current can be varied. That means the Ohm's law defines whenever the voltage is increased, current also increased. That means voltage is directly proportional to current. This is the concept behind this Ohm's law. Similarly, here instead of a single resistor, we can use two or more resistors. Both are connected in series and parallel concepts can be viewed here. So let us see when the two resistors are connected in series. For example, here I connect two resistors. The resistors are connected with the source, that is DC source voltage, which is connected to ground. So here the positive terminal of voltmeter, here the positive terminal of power supply is connected with this one resistor, and another resistor terminal is connected with first resistor. And here we can name this first resistor is considered as R1 and the second resistors are considered as R2. So both are connected in series manner, and one resistor terminal is connected with power supply plus terminal, that is anode, and the cathode of battery is connected with this second resistor another terminal. So this is a concept behind the whenever the two resistors are connected in series. Similarly, if you want to consider 3 resistors or 4 resistors etc. up to till Rn, so we can find the resistance value for the total number of resistors connected in the circuit. So the formula is Rn is equal to R1 plus R2 plus R3 plus etc. till Rn. So total number of resistor value is n number, means corresponding number of resistors are denoted as Rn. So here I take only two resistors. So R1 and R2s are named as a resistor value. So let us go for the concept. The total resistance means here I just assume the R1 value is equal to 5 volt, 5 kilo ohm. For example, R1 is equal to 5 kilo ohm and R2 equal to 10 kilo ohm. So now we can find the total resistance value. We have to add these two resistance value. The total resistance Rn, total resistance Rt, which is equal to R1 plus R2. Total value is equal to 15 kilo ohm, because we can add this resistance both R1 and R2. So at the time we will get R1 value is 5 kilo ohm, which is added with R2 resistor value 10 kilo ohm. Finally, we will get 15 kilo ohm. So 15 kilo ohm is the total resistance when the two resistors are connected in series. So this is a concept for whenever the resistors are connected in series manner. So depends on the number of resistors are connected in series. According to that, we can find the total resistance value. So this is can be denoted as RT. Okay. So let us move to the concept. Let us consider this virtual lab. Here two resistors are connected, R1 and R2, both are connected in series, and the voltmeter is connected in parallel with this two resistance, and ammeter is connected with series. So now we can find the voltage law concept, that means Ohm's law concept. Here here we can set the DC voltage. So let us set DC voltage value is equal to 5. So initially I just take R1 equal to, you can consider below 15 voltage. Here I consider R1 value is equal to 9. and R2 value is equal to R1 value is equal to 6 and R2 value is equal to 8. Now we can add to table. So what are the values we have given? That is enabled in this experimental table. R1 value is equal to 6 kilo ohm, R2 is equal to 8 kilo ohm. Whenever we add these two, we will get the R equivalent or R total resistance value for RT equal to 6 plus 8, 14 kilo ohm. So the voltage what we have applied in this voltmeter or DC voltage VDC is equal to 3 volt. So according to that, the current value is 0.214 milliamps. This is can be calculated with the help of V equal to I into R, Ohm's law rules. Now we can plot this. We can able to see the value. So what is the value we have already given? So for that we can able to draw this value. Again the voltage and current relation which is available in this graph plot area. So now we can again maintain the same resistance value. R1 is equal to 6 kilo ohm, R2 is equal to 8 kilo ohm. Let us change the DC voltage. Instead of 4 volt, here I increase voltage is equal to 6. Again add to table. Now the value will be changed in experimental table. The voltage is equal to 6. So according to that, we can find the current value in terms of milliamps. 0.429 is the exact answer. So the voltage is increased, at the same time current also increased. Now again you can add this value to table and plot. So we can able to get the linear graph. That is the voltage is increased, current also increased. Again, if you want to measure one more or two more values, you can increase this DC voltage. Instead of already given value, here I change this value and add it to the table. Now the voltage value is increased by 2 and the DC voltage value is equal to 6. For that, our resistance value and current value are mentioned here, and we just put a click a plot, and again we will get a linear curve. Likewise, we can increase DC voltage again, that will be added into the table, and finally plotted, you will get a linear curve. So this is a relation between Ohm's law, that is voltage and current with the resistance. When the resistance are connected in series, that is more number of resistors can be taken here instead of single resistor. So I think everyone can understand this concept. Kindly see this video and put like for my video. Subscribe my video also. Thank you all.